We're now going to look at how to form the equation of a curve given its gradient and a point that it goes through. This is a question off the recent mock paper that we did. And so we've got the gradient, which is, this is what h dash means. So if y equals h of x, then that means a function of x. And what we've been given in the question is that h dash x is actually the gradient of this curve. And so h dash x is 15x root x minus 40 over root x. And we know that the curve is also going to go through this point. So what we can do, we're trying to find the equation or find hx. So we know that y is actually the integral, because integration is the opposite to differentiation. So it's the integral of the function of the gradient, so h dash x with respect to x. So what we're going to do is we're going to integrate this here. And before we do that, we could do with actually sorting out these roots and putting them into index notation. So we know that the 15x is then going to be times by x to the half, because that's what the root of x is, and it's also minus 40 over, and this is x to the half on the bottom, yeah, in the denominator. But actually, if I want, and we'll need to for this question, we actually can write it in the top line, and so in the numerator, if we make the sign on the power negative. So that's better for integration. And just going to tidy this bit up again. So the x and the x to the half. So when we multiply in things with powers, what we would do is we add the powers. So that's actually an x to the power 1. So if we add 1 to the half there, we're actually going to get 1.5, which is 3 over 2 if we write it as an improper fraction. So that would be 15x to the 3 over 2, and then minus 40x to the minus a half. So that's what we're going to integrate. So we're going to say that y, which is equal to h of x, is going to equal the integral of this 15x to the 3 over 2 minus 40x to the half, or minus half. And we're doing an indefinite integral at the moment because we don't have limits for this one. What we do have is the point that it's going to pass through. But we're going to integrate this as an indefinite integral. So we can follow the usual procedure. So what we're going to do is we're going to raise the power by 1, and we're going to divide by the new power. So if we do that, then if we raise the power by 1, it's now going to become 5 over 2. So the power on the x is 5 over 2. We've got 15 that we already had. But what we're going to do is we're going to divide by 5 over 2. Well, dividing by 5 over 2 means we can actually multiply by the reciprocal of 5 over 2. So the reciprocal of 5 over 2 is 2 over 5. So in other words, what I've done is I've just inverted the fraction and changed it from divide to multiply. And that makes it a bit easier to deal with. And then we're going to do the same here. So if we add 1 to the power on the x there, add 1 to minus a half, I actually get positive a half. And what I'm going to do is divide by the new power. So I'm going to be dividing by a half, which is actually the same as multiplying by 2. So the minus is going to stay as a minus there, because we're going to be multiplying by positive 2, and it's going to become 80. So I've divided the 40 by a half, which has the effect of actually multiplying it by 2. And then what we do need to put on is plus c, because it's an indefinite integral. So now what we're going to do, we're just going to tidy this up. So if I divide the 15 by the 5, I'm going to get 3, and then times it by the 2, I'm going to get 6. So I've got 6 x to the 5 over 2 minus 80 x to the half, and then plus c. So that's what we've got for h of x at the moment. But we need to actually work out the value of c. And for that, we're going to use this point here. We're going to use 4,19 as our value. So if we replace both the h of x, which is y, by the 19, and the x value by 4, then that allows us to work out the value of c. So we could say, well, 19 is equal to, and then we've got 6 times 4 to the 5 over 2. So just simply replacing the x by the value that we've been given. Minus 80, and then it's going to be times by 4 to the half plus c. So I'll continue working this out up here. So what we've got is 19 equals 6 times, and then we need to first of all take the square root of 4. That's from the bottom of the fraction. So that's obviously 2. I'll do this in a couple of stages. And then we're still going to take the power to the 5th power of 2. So I took the square root of 4, which is the effect of the bottom of the indices there. And then we're going to have minus 80 times the square root of 4, which is obviously 2. And then it's plus the c, which is what we're trying to work out. So we're just going to sweep through this again and tidy it up. So we've got 19 equals, so 2 to the power 5 is 32. So 6 times 32 minus 160 is, and then minus 160, and then plus the c. If we tidy that up, then what we get is 19 equals 192 minus 60 minus 160 plus the c. So that's 19 minus 32 plus c. Take away 32 from both sides, and what I'll end up with is c is equal to minus 13. So then all we need to do, let's write this up at the top, is rewrite our equation that we had for hx, but replacing the c by the value that we've just found. So we can say that hx is equal to 6x to the 5 over 2 minus 80 x to the half, and then now c, which is what we just found, is minus 13. And that's it, we've done it.